Alright, so an identity matrix is the one of matrices, or several different ones. And if you kind of think of where this is going to be useful, if I, if I multiply by 1 on the right, I retain the value. If I multiply by 1 on the left, I retain the value. But we're trying to get a division of some sort. That's what we're aiming for. So we want to, what we're going to do next is we're going to say, okay, what is the essential, the version of a reciprocal? The technical term here is a multiplicative inverse. And that is the number that we would multiply, so if we're talking real numbers, the number that we'd multiply by 3 to get 1. In the case that we're doing here, we're going to say A inverse is the matrix that we would multiply by A to get the identity matrix. In order for this matrix to even exist, A does have to be a square matrix. So, if A is a 2 by 2 matrix, A inverse would be a 2 by 2 matrix, and the appropriately sized identity would also be a 2 by 2 matrix. If you're doing this on the calculator, you can just type in your matrix and then use the inverse key. This works both on the TI-83. It has a specialized key for it. This is actually the button that we've been pressing when we're dealing with matrix. This button right here will give us the inverse. It'll give us the -1. If you're using the TI-36X Pro, there is a special key to go into the to an exponent and just type in -1 in the exponent, and that's how you'll do an inverse. Alright, so if we want to find the inverse of this matrix, I'll go ahead and do this on the calculator. There are ways to do this by hand, but it uses the Gauss-Jordan method. I'll go into that after I get through it on the calculator in case you're interested, but I'll put it at the end of this video, so if you want to, you can just skip it and move on to the relevant material. Alright, so the first thing I'll do is I'll enter the matrix, whether we're doing this on the TI-83 like I am here, or on the 36X Pro. It's pretty much the same sort of thing. You're going to go to Edit. You're going to say this is a 2 by 2 matrix. We're going to do 2, -3, 1, 5. You're going to quit back to your home screen, and we want to deal with matrix A, so I'm going to go back to the matrix menu and in the Names tab. I'm going to select A to have it output here, and I would go ahead and press this key on this calculator. On the other calculator, you're going to press the exponent key and then just type in -1 and hit enter. And in any case, we get some weird repeating decimal. At this point, I would want to go into the math menu, and this the key is located slightly differently on the TI-36X Pro, but it's still in there. You'll go math, and then you'll want to convert it to a fraction. I'll just do that, and this gives me the calculator attempts to convert this to a fraction, and you can see that is the inverse of this matrix. I'm going to go ahead and write this down so I can test to show you and verify that this is actually the inverse. We have 5/13, 3/13, -1/13, and 2/13. That's the inverse, A inverse. So how I'm going to verify that this is the inverse is I'm going to store this in matrix B. I'm going to put this in here, 2 by 2. And then I'm going to try multiplying them together and make sure it comes out right. This is -1/13 and 2/13. Alright, so I have A and B stored in this calculator. If I take A times B, you can see I get the identity matrix. This is just like taking a number times its reciprocal gives us 1. An interesting thing about this is the identity, or the inverse matrix, actually doesn't change if we do left multiplication versus right multiplication. It actually still works. You can see A times B and B times A are the same. They're both the identity matrix. So in other words, another way of saying that is that the inverse of an inverse is just the original matrix. So if I was to take the inverse matrix of an inverse matrix, it kind of goes back to the original one, which is nice because you see that same thing when we're talking about real numbers, the reciprocal of the reciprocal. If I was to, take the reciprocal of 1/3, I would get back to 3. All right, so let's look at how to do this with the Gauss-Jordan method by hand if you're interested. If you're not interested, feel free to skip the rest of this video. All right, so to do the Gauss-Jordan method to find the inverse of this matrix by hand, it's a little bit messy because we're dealing with some fractions here. So actually, I'm going to choose a slightly different one so that I'm not dealing with fractions. Instead, I'm going to use this matrix 2, 5, 1, 3, and I'm going to find the inverse of this one, just because I don't want to deal with fractions in this. I just kind of want to show how it works. So to use the Gauss-Jordan method to find the inverse of C here, what we're going to do is I'm first going to adjoin. I'm going to make another augmented matrix. I'm going to take the identity, the appropriately sized identity, and tack it on to the right of this matrix, this 1, 0, 0, 1. It's just a 2x2 identity matrix. Other than that, I just have the original matrix here. Then I'm going to follow the Gauss-Jordan method, which is to say I need to establish 1s along the diagonal and 0s elsewhere. Well, I already have a 1 here, so the first thing I'm going to do is I'm just going to swap these around because that'll get me the 1 up there without using division. Let's see, we get 1, 3, 0, 1, 2, 5, 1, 0. Alright, so that gets me the 1 there. To make this one into a 0, I'm going to take row 2 minus 2 times row 1, and that's going to become my new row 2. So I'm going to take this row minus 2 of these, because I'm saying 2 minus 2 times 1. Alright, so that'll give me, I'll write it down here, so I'll just keep going down. Alright, 1, 3, 0, 1 doesn't change. I'm going to take this one minus 2 of those, which gives me a 0. This one minus 2 of those, that's 5 minus 6, which is negative 1. This minus 2 of those, which is, well, I guess just 1. And this one minus 2 of those, 0 minus 2 is negative 2. Alright. Next off, I want to establish a positive 1 here, which means I'm going to multiply through this row. Negative 1 times row 2 becomes my new row 2. I'm just going to multiply through that row by negative 1. Let's see, that gives me 1, 3, 0, 1, 0, 1, negative 1, 2. And lastly, I want this number to be a 0, which means I want to I'm going to take that first row and subtract off 3 times this row, because 3 minus 3 of these will give me a 0. So that's row 1 minus 3 times row 2 will give me my new row 1. So that'll be 1, this one minus 3 of those is 1, this one minus 3 of those is 0, this one minus 3 of those, minus a negative number, this is just like saying 0 plus 3, it gives me a 3 there. And here we get this one minus 3 of those, which is going to be 1 minus 6, which is negative 5. We get 0, 1, negative 1, 2. And you can see I've completed, I have the augmented matrix where the identity is now on the left-hand side instead of it being on the right-hand side. And this matrix here that's now on the right-hand side is actually the inverse that I'm looking for, the 3, negative 5, negative 2, or negative 1, 2. So C inverse is 3, negative 5, negative 1, 2. So if we're trying to do these things by hand, that's one way to find an inverse matrix. There are definitely other ways, especially with a 2x2 matrix like this. There's actually a much easier way to do it. It's using a determinant and doing all that sort of stuff. But we already saw the Gauss-Jordan method, and this is a relatively straightforward way of finding the inverse. So that's the way I'm showing here. All right.